So today we're going to go over section 2.7, parent functions and transformations. Okay, so these 5 examples on your paper show parent functions for each special type of graph. So when I talk about a parent function, I'm just saying it's the simplest form of a graph of that type of function. So on a constant function, you just have y equals a number. The linear function is also the identity function, y equals x. So your graph is going through the origin and it has a slope of 1. Absolute value function, the vertex is on the origin and you just have a slope of 1 in either direction. There's no transformation taking place. The greatest integer function, so you have a point at 0, 0. The steps are 1 unit long and they're 1 unit apart. And then you have a quadratic function. When you have the x squared, that makes it a U shape. It's quadratic, a parabola. And this is the easiest type of graph for a quadratic function because the vertex is at 0 and the parabola is going up in a normal slope. Okay, so looking at the transformation right underneath your graphs gives you some examples of transformations. Y equals ax plus b. The a in front of the x changes your slope to make it either steeper or more shallow. B moves the graph up or down, so it changes your y-intercept from 0 to something else when you have a b. Okay, on the other side you have a step function example, and I wrote next to it a parabola example. They're using b and c to represent numbers. I'm using h and k to represent numbers, but it's the same type idea. We're both using a outside the parentheses or the step function to represent numbers. Okay, so this a outside is going to change the shape. So it's going to make it either go up faster or go up slower, make it wider at the bottom. B inside with the x, or h inside with the x, is going to shift your function left or right. C outside the step, or your k outside the parabola parentheses, will move it up or down. Okay, and one other thing is, if your a is negative, it's going to flip your graph over. It's going to make it reflect. So I have your key concept from page 112 on the back here because it gives you more detailed information. And I'm going to give you a second to copy that down because I would like for you to have some kind of a reference as you're going through this stuff. Okay, so let's go over this. So when you have a number being added inside the parentheses or inside your step or inside the absolute value, it's going to shift your graph left or right. I'm sorry, left. When it's added, you go left. It's the opposite of what the sign is when it's inside the parentheses. That's how I always think about it. Okay, so if you have a number that's being subtracted, it's going to move it to the right. On the outside of the parentheses, though, it's going to go with whatever the sign is. So if you have a plus some number, it's going to move your graph up. If you are subtracting a number, it's going to shift your graph down. Any questions on those? Okay, then we have the reflections. If your negative is outside the parentheses, you're reflecting in the x-axis. If you have the negative inside your parentheses, it's going to be reflecting in the y-axis. Okay? This could always also just be like with no parentheses. Okay? That's the same thing too. Okay, so here at the bottom we have dilations. Let me tell you something real quick and then you can write this down, okay? Let me tell you first though. So we have A outside the parentheses. If it is bigger than 1, so that means a whole number, or it could be like 5/4, just something bigger than 1, it's going to stretch it vertically. Well, it's really the same thing when it's inside the parentheses, except in the book it's saying that this compresses horizontally. So I think what they're trying to tell us is when the number is outside the parentheses, it affects the y value. When the A is inside, it's affecting the x value. Okay, that's what the difference is. But these two, really, they look the same when you're graphing it. So if your A is between 0 and 1, like 1/4, 2/3, 5/6, something like that, it's going to compress vertically. It's going to make your graph go up way slower. Okay? Same thing's going to happen if it's inside. It's going to make your graph go up way slower. Okay, so go ahead and jot those down. But these are your dilations when they're asking you to describe the dilation. That's what they're talking about. How is it stretching? Okay, so this bottom part is when they're asking you what kind of dilation. The middle part is when they're asking you what kind of reflection is happening. Okay, and the top part is when they ask you what kind of translation or transformation. Those are interchangeable words. So let's do a couple of examples. So in your assignment, they are asking you to describe what's happening and to graph the equation. So we're going to do both of those in your notes. Okay, in your notes, I don't mind if you don't use graph paper, but in your homework, you need to use graph paper. If you don't have some, you can borrow some. If you can't borrow some when you get home, you can print some off the computer, because you can go to a website that lets you print graph paper, and you can print some. Okay, so number 1, we're going to describe the transformation and then graph this. So the transformation here, what kind of a shape is this going to be when you graph it? A line. And your slope is different than the parent function because it has a 2 in front of it. So you would say the slope is steeper. Okay, and then your graph. Now when you do this on your paper, as far as the linear equations go, I'm okay if you don't put a table of values, but when you get to quadratic equations or absolute value equations, you need to have a table of values, okay? So my y-intercept is at 0, and then the slope is 2 over 1. So I'm just going to count the slope out a little bit. And when you're doing your graphs, you need to make sure and make them neat. Don't be sloppy with your shapes and just scribble something on your graph. That's because that's not going to work later. It's going to make you get some wrong answers. So you got to make sure that you're trying to be as neat as possible. Okay, and there's your graph. Any questions? Okay, so let's look at number 3. What kind of shape is number 3 going to be in? A V shape. It's absolute value. Okay, so absolute value problems, they're not going to have a squared term either. All right, they're just going to be like a line, except it's going to be a V shape because you can't go in the negative direction. So inside your absolute value, you have a shift going on. Is that going to go left or right? It goes the opposite direction of your sign when it's inside. So this is actually going to go 3 units to the right. So I would say shift 3 units right. And what about this -1 outside? What is that going to make it do?
1 unit down.
Okay. Shift 1 unit down. All right, so now the table of values. Your first x value that you want to pick is whatever is going to make inside this absolute value equal to 0. So what should I pick for x? 3. So when I plug 3 in, I get 3 minus 3. So that'll make all of that 0. And y is going to equal -1. So I'm going to graph that first point. Three, -1. Okay, there it is. That is my vertex point. So from this point, I want to go pick an x value on either side. And I want to try to get the same distance away from this vertex point. So if I choose 4 on the right side, what point for x would I choose on the left side? 2. They're both 1 unit away from that vertex 3, -1. So when I plug 4 in, 4 minus 3 is 1. Absolute value of 1 is 1. And 1 minus 1 is going to be 0. And I plug the 2 in. 2 minus 3 is -1. The absolute value is going to be +1. And 1 minus 1 is 0 again. Okay, so now I have 3 points I can draw my shape. And that's going to be your graph. So you really do just need 3 points on these graphs. Just try to pick good points and be neat. Any questions on this one? Okay, so why don't you guys try number 5 on your own, and I'll do it up here. So you're going to describe the transformation and then graph your equation. Oh, and let me add something to number 5. Sorry, I forgot. Let's put a negative sign out in front of the parentheses. So it's negative parentheses x minus 1 squared minus 2. Let's see what you get, okay?